Today's lesson is about the proof of some trigonometric ratios. Trigonometric ratios are very important formulas in trigonometry. So be concerned and see how to prove some trigonometric formula. Remember to subscribe, like and share. So now let's start. Let us consider the triangle ABC, which is right angled, So we have the triangle ABC, ABC. This is the adjacent. This side is called adjacent side. The base of rectangle triangle is called adjacent side. The height BC is called opposite side, and the segment AB is called hypotenuse. This is B, the side B, the angle. The letter B, capital B, denotes the angle B, and B denotes the side opposite to angle B, called small b. And here it is C, small c, and the side BC can be also denoted by the side by A. So let's consider an acute angle alpha. Here at A, we can denote 6 trigonometric ratios using this triangle. We can denote 6 trigonometric ratios using this triangle. The first one is sine of alpha. Sine of alpha is equals to opposite side divided by hypotenuse. This means that sine of an angle alpha, opposite side is equal to A, hypotenuse is equal to C. This is the first trigonometric ratio. The first trigonometric ratio called the sine. The sine of an angle alpha is equal to the opposite side. The opposite side divided by hypotenuse. So now, let's move for the second one. The second trigonometric ratio, which is very important, is cosine of an angle alpha. Cosine of an angle alpha is equal to the adjacent, this AC, the adjacent divided by hypotenuse. So now, cosine of an angle alpha is equal to adjacent side divided by hypotenuse. This will be equal to opposite side is denoted by B divided by hypotenuse denoted by C. This is the second trigonometric ratio. Let's move for the third one. The third one is called tangent. Tangent of an angle. Tangent of an angle is denoted by tan. Tangent of an angle is denoted by tan of an angle alpha. Tan of an angle alpha is equal to the opposite side divided by adjacent. Opposite side divided by adjacent. So now, since tan alpha is equal to the opposite side divided by adjacent, tan alpha is equal to opposite side divided by adjacent side, and will be equal to the length of BC called the edge divided by adjacent B. This is the third trigonometric ratio. The third out of 6 trigonometric ratio, the third one is called the tangent of an angle. Tangent of an angle is always equals to opposite side divided by an adjacent side. The fourth one, the fourth trigonometric ratio is called the secant. Secant of an angle alpha. Secant for an angle alpha is noted by sec alpha. Sec alpha, which is equal to the inverse of cosine. Inverse of cosine is equal to the inverse cosine. Sec alpha is equal to 1 over cosine. Cosine of an angle alpha, which is equal to the inverse of B over C. This means that sec of an angle alpha is equal to C over B. C over B. This is the fourth trigonometric ratio. The fourth trigonometric ratio is called the secant and is equal to the inverse of cosine, which is also equal to the hypotenuse divided by adjacent. Hypotenuse divided by adjacent. So let us move for the fifth trigonometric ratio. Fifth trigonometric ratio is called cosecant. Cosecant of an angle is the inverse of sine of that angle. So secant of an cosecant is noted by CSC. Cosecant of an angle alpha is equal to 1 over sine. 1 over sine of an angle alpha, which is equal to the inverse of sine of alpha, and it will be equal to the inverse of sine alpha is C over B. C over B. This is the fifth trigonometric ratio. The last one is cotangent. Cotangent of an angle alpha denoted by cot of alpha. Cot of alpha is the inverse of tan. Cot of alpha is equal to 1 over tan of alpha, which is equal to cosine of an angle alpha divided by sine of an angle alpha, and finally equal to the inverse of tan in ratio. So cotangent of an angle alpha is equal to B over A, which is equal to the adjacent divided by hypotenuse. Remember that for tan, it is the opposite divided by adjacent. For cotangent, is the adjacent divided by opposite. These are 6 trigonometric ratios, which are fundamental formulas while dealing with trigonometry. So let us move for some examples about trigonometric ratios or not. Let me tell you another important formula Another important formula, which is fundamental formula of trigonometry. When dealing with trigonometry, there is an important formula we have to know so that we can deal with trigonometric ratio easily. So, the fundamental formula of trigonometry is derived from a unit cycle. For a unit cycle, the cycle if the center 0, 0 and the radius 1. A unit cycle the radius is equal to 1. Let's consider the triangle inside, and this is the C, and this is an hypotenuse C, which is equal to radius and is equal to 1. This is the opposite side, and this is the adjacent. For a unit cycle, from the sixth trigonometric ratio, C is equal to 1. C is equal to the radius and is equal to 1. So, we have seen that sine of alpha is equal to A over C, and C is equal to 1. This means that A is equal to sine of alpha. Also, cosine of alpha is equal to adjacent divided by hypotenuse, which is equal to B over C. This is B and this is A. And then since C is equal to 1 for a unit cycle, we can derive that B is equal to cosine of alpha. Let me take another chalk. I'm coming. B is equal to cosine of alpha. By using Pythagoras theorem, the square of the hypotenuse is equal to the sum of the square of the adjacent and opposite. So we can have opposite square plus adjacent square is equal to the hypotenuse square. Since A is the adjacent and is equal to sine alpha, we have sine of alpha square plus cosine of alpha square, which is equal to C square, and C is equal to 1 square. We can get another formula which is equal to sine square of alpha plus cosine square of alpha, which is equal to 1. This formula is equal to the fundamental formula or fundamental relation of trigonometry. Sine of alpha plus cosine of alpha is equal to 1. For all angle alpha, the square of the sine of that angle plus square of cosine of that angle will be equal to 1, and this one is called fundamental formula of trigonometry. This is called the fundamental formula of trigonometry. So let us move for example. We are going to do examples so that we can use this fundamental identity or formula to prove other formula or other identities. To prove other formula or other identities. So, example, use the fundamental formula of fundamental formula of trigonometry to show that one plus tan square of an angle alpha is equal to sec square of alpha. The second one is 1 plus cotangent square of alpha is equal to cosec square of alpha. Solution A, to show that 1 plus tan square of alpha equals to sec square of alpha. From the left hand side, 1 plus, remember tan, we have seen that the tan of an angle alpha is equal to sine divided by cosine. Sine divided by cosine. So we can write this is equal to sine square of alpha divided by cosine square of alpha. Cosine square of alpha. This will be equal to, we can put this fraction and this number on the common denominator so that we can get this cosine square will multiply here at 1 so that we can get cos square alpha plus sine square of alpha divided by cos square of alpha. From the fundamental relation of trigonometry, we have seen that cos square of an angle alpha plus sine square of an angle alpha is equal to 1. Thus, this will be equal to 1 divided by cosine square of alpha. Cosine square of alpha, remember that 1 over cosine is equal to sec. This means that 1 over cosine square of alpha is equal to sec square. Hence, this will be equal to 1 over cos square, and then finally it will be equal to sec square of alpha. I think this is proved, and everyone can see how 1 plus tan square is equal to sec square. So, for number B, we have 1 plus cosine square of an angle alpha is equal to cosec square of alpha. Also, from the left hand side, we have 1 plus cotan is equal to cosine over sine. We have cosine square of an angle alpha divided by sine square of an angle alpha By putting on the common denominator, we can get sine square of an angle alpha plus cos square of an angle alpha divided by sine square of an angle alpha. Also, from the fundamental relation of trigonometry, we have seen that sine square plus cosine square is equal to 1. Is equals to 1. So now we can have 1 divided by sine square of alpha. 1 over sine, we have seen that 1 over sine of angle alpha is equal to cosec. Cosec. This means that cosec square, 1 over sine square is equal to cosec square. 1 over sine square is equal to cosec square, So finally, we will have cosec square alpha, which is equal to the right hand side. This is how we can prove 1 plus cotangent square is equal to cosec square. So, trigonometric identities are so many, but some of them are 6 which are fundamental, and the next other important formula is the fundamental relation of trigonometry, which is said that cosine square of an angle is plus sine square of an angle is equal to what? To 1. You can use this formula to prove other trigonometric identities, as you have seen here. We have proved that 1 plus tan square is equal to sec square, and 1 plus cotangent square is equal to cosec square in this way. So, and I'm going to give you a homework so that everyone can exercise and try to use these fundamental formulas and the 6 trigonometric ratio to prove these identities, and you will type in the comment to reflect about the solution you got, or if you fail, you will comment and ask me to collect those exercises. But I think as you have studied this, everyone will do them easily and easily. So let me give you a homework. Everyone will exercise after studying the 6 trigonometric ratio. Everyone will exercise and try to find how these identities are equal. Prove the following identities. Prove the following identities. The first one is that cotangent square of x divided by 1 plus cotangent square of x is equal to cosine square of x. The second one is that 1 over sec of x minus tan of x plus 1 over sec of x plus tan of x is equals to sec of x. This is the homework everyone will do after watching this video and knowing the 6 trigonometric ratio and other important formula called the fundamentation of trigonometry, and use this formula to prove this identity. Please, I want your comment so that I can know the lesson has been understood and this exercise has been done clear. Thank you for watching.